section is dimension implications and your standard procedures. Let's get into here. So we'll hit the very first one is your radii. Yeah. So how to do dimensioning for your radius. So let's take a look at that. So the very first one is our regular. Yeah. So you have a radii for this arc, and we usually use radius, which is r, and then 0.750. Yeah, you can see like how we can be able to put the value inside of the arrow. Okay, so we have an arrow in, and we call this type arrow in dimension. You hardly see that. We usually put that on side. Yeah. That's the first one. And the second one, we can also write the radius of this little arc like this. See? Arrow in, this one is arrow out. The next one, arrow in, arrow out, and here the arrow is, in and out, which is in and also out. So we call the arrow in, arrow in and dimension is out. Yeah. Arrow in, dimension out. And this one, is when we don't have space. At that time, we're gonna use this type of symbol. Okay. So what is this? That's just your foreshortened, right, symbol. Don't forget that, like a little bender line. So again, here, foreshortened symbol. Then the next one looks like this. Arrow out, dimension out. Okay. Here, dimension in, arrow in, dimension out. Okay. Arrow out, arrow in, dimension out. No space. You're gonna use a foreshortened, value in, which is your dimension in. Here, dimension out, your arrow is also out. Out of what? Out of your feature, yeah? Okay, don't forget that. No. Alright. Okay, so here you have 1, 2, 2 foreshortened radius, see? Right here, yeah? That's your one foreshortened and showing you the spherical, radius, and the other one is also here, yeah. So you can see the broken line right there. So this is the center point, yeah. I wish we are like showing you with a broken dimension line for the center point of this arc, center of the arc. So from here to here is your radius. And this is also using a foreshortened line right here, dimensioning line, of course. This is just showing you from here, this surface to the center is this much, but because of the limited space, so we use a foreshortened line, because you have no idea, where to put this thing way out for 35 units so far, so therefore we just put it in here, and then we do foreshortened, meaning line from here to here is actually so far away, and this much far away, so you won't make a mistake. Okay, next one. Now we get into the round holes and the depth, right, characteristic. So here we have the arrow in and dimension out, and we call this dimensioning technique, a diagonal diameter. Good. This is your diameter, and that's your diagonal line. Looks like it, so we call that diagonal diameter, and it's normally used with the larger diameters, and we can place this dimension, of course, outside, like here, and we put the arrow of the dimension line inside, of the circle. A little bit different, so many different ways, to dimension. And the next one here is arrow in, dimension in. Your arrow is in, dimension is in, and dimension in this diameter, or dimension in that diameter, So here we use a leader line, yes. Pretty, this is more common type we use. The next one, showing you the diameter of this. Okay, here is your depth, right? And it is your cylinder. So the cylinder diameter is this much, 0.250, and the depth is 0.62. Then we have through. If you say through, it's right here. Yeah. Another way of dimensioning. Yeah. The same diameter. This is one way, and that's another way. Your dimension out, your arrow is out. Yeah. Here, dimension in, arrow in for this step. Yeah. Alright, next one is your method for dimensioning angles. So let's take a look at it. So we'll get into angular dimensions. How are we gonna write it? So here's the angle that we write. I'll put the value right in it. Of course, your degree and your minute right there. This is just your length, yeah, from here to here. Line out, value in. Here, line in and value in. Yeah. Here, arrow in, dimension in. Dimension out, arrow out, because the angle is small. Okay. The next one, dimension in, arrow out. Still a smaller angle. Arrow in, dimension out. Yeah. So a little bit bigger angle. So now various different kinds, and it's just showing you where the angle, yeah, is measured from. This little red, see, plus sign is showing you the vertex of the angle. It's meaning the two sides of the angle, yeah, first and second side. This we call it the side, like a little arm, yeah. So like your tweezer, yeah, and so vertex, first arm and second arm here. All right, and then we'll get into example, yeah. All right, so here's an example how to do angles. So here, dimension in, arrow in, from here to here, the vertex is right here, the angles, yeah, arms are right there. Pretty easy. Alright, next one. Alright, so now we can see it. So here we have polar coordinate dimensions. Polar main lines is going on here, circle, yeah. So here, look at that angle, another big giant angle, yeah, circle, angle between the centers of these circles, this angle, yeah, diameter, of course, and you have like many different angles right there, 120, 18, 18, in between little tiny circles. Yeah, from here to here, you add this 2 up, of course, it's going to be 30, yeah, 36. I hope you can see it. Yes, I can go slow. So from here to here, yeah, adjacent medium circle, 120 far away from each other. From here to here, little circle and medium circle, 18. If you add 18 2 times, you're gonna get from here to the other little circle, okay? You can also calculate from here all the way to here, of course. So that's just your algebra, yes? Addition and subtraction. Alright, next one. Here's a, for accuracy wise, yeah, this type of a wedge shape is not very accurate. It's just showing you the same example here, yeah. It's just showing you like if you have like a web shape tolerance zone, then it's not that accurate, okay? So that's all you have to understand, yeah. This type of symbol right here showing you the wedge. See the little wedge shape tolerance zone, and you take it like if you ever see this symbol, you're gonna take it. Oh, it is less accurate because of that type of axis control. Alright, next one. Alright, here you can see the rectangular coordinate dimensioning. See how center to center are dimensioned in rectangular extension lines and dimension lines. See, it's a little bit different from this polar, yeah, coordinate system dimensioning. It's kind of messy, yeah. This is cleaner to see it. Okay. Alright, so this one is continuation of your rectangular coordinate dimensions, and see this little symbol right here with your circle, and then see this little square right in there. So just showing you this tolerance, you know, tolerancing, the type of tolerancing is square or rectangular tolerance zones. So that method is used for your tighter control, you know, a little more accurate. This guy is really bad, and yeah, so I hate this. Trying to fix all his slides. It's bad. Okay. We're not supposed to like change his stuff, so we gotta give credit to the author. Okay, so I did change it, but I changed it for the because it doesn't look good. So anyways, here, yeah. So you can see this rectangular coordinate dimensions, and here that's your tolerancing established with we are using. See, just by looking at this, that you know that you're using the rectangular coordinate dimensioning method. Yeah. Here we go back the less accuracy. So wedge, little shape right there. So we're just telling, hey, we're using the polar coordinate, yeah, wedge tolerancing method. Okay, so dimensioning symbols, we'll get into it. So this time we're gonna learn how to use the leaders, yeah? Okay, so let's see how we do that. So here are your leaders. Look, different types of leaders. This type, that type, this type, yeah? And then that. So all the leader lines, see, like how we make sure the arrowhead, they are in contact, all right? They are completely in contact with the object lines that they're defining, yeah? Defining this, and the circle, and then this one is just a polish because it's showing inside, okay? Alright, so leaders, you have to orient it on the drawing, so the angle, yeah? Leader lines always have a little angle. See, it has like, meaning like there's a little slope when it lands on the feature. So horizontal vertical leader should not be used because you can't use like this straight horizontal or straight vertical. You have to have a little angle, yeah, for the leaders. Then the angle, right, for the finished symbol leader, you gotta adjust it, meaning like you can't use a very wide angle. See, there's no wide angle like this. And each meaning you cannot, yeah, you cannot be misunderstood. You cannot understand the wrong way because we, when we draw it, we make sure that everybody clearly understand. Yeah, by reading the leader line on labels. The next one is your extension line. Yeah, we have, see, extension lines, and you have dimension line in between the extension lines, and we usually draw it perpendicular to each other. Yeah, so this, you can't draw it like diagonally, you have to draw it perpendicularly between the dimension lines and the extension lines. So that means dimension lines got to be perpendicular to the extension lines. Yeah, why do we need the extension line? Because for accuracy. Yeah, so kind of like giving the boundaries of where and to, from where to where is this value. Sometimes you're gonna deal with the oblique angle, yeah. At that time, we can give the dimension line a little bit slender like that, yeah. Not perfectly perpendicular like this, but slanted. See. Of course, here is the arrow out and value out because of the limited space that we are defining between here and here, here and here. This one is another example that you can see here, yeah. So when you take a look at it, see this extension lines. Why? It's because kind of like a small space that you're dealing with, so we slant it outside of the part. We gotta do it like that because of the space limit. You can't do the standard dimensioning because it's gonna clutter your drawing. So that way, in order to save the space, we use this type of extension lines and dimensioning. Alright, then let's get into, then we're gonna get into features, like a little bit different features right there. So that features is formed by this die arc right here. So arc, so we're dealing with the die radii, radius. So in that case, you will have to use, see, like there's a little angle for the dimension between these two extension lines. So I mean, like the extension line is not perfectly perpendicular to each other in the standard dimensioning way, nor totally slanted, but it's kind of like a little, taking a little angle right there in order for us to be able to define this arc. See, because the arc is joining the two rectangle right here. So we have 4 arcs right there. So 1, 2, 3, 4. So in order for us to dimension this value from here to here, then we have to use, because of this is a joint, the joint between the arc and this feature. So we call that the intersection or intersecting points. At that time, we will use this type of dimensioning. Okay, so let's take a look at this orientation of this dimension value. See how different this is, like horizontal, and that one is vertical. So we have this uni direction, we call it, and here the vertical, we call it aligned. Okay, so most of the time we use this, okay, but sometimes you're going to see like that. Alright, next, this is just showing you the orientation. So let's see what they are. Orientation of dimensions. So here, look at that. Just talking about how we do the aligned dimension. So aligned dimension looks like this. Okay, not very popular anymore, but some companies they still use it. You gotta understand there is its limitations. Why it's not currently we don't use it because it's sometimes very difficult to read it, because they are parallel. Parallel, the value is parallel to the dimension it's making, so it's kind of confusing sometimes, especially like when you deal with the circle, and then you have to rotate around to read it. So it's kind of like difficult to read, and you will get a headache to read in a circle if you use an aligned dimensioning system. Alright, so here you can see the several dimensioning concepts. All the value in, arrow in, value out, value in, arrow out, yes, and so and so. Line crossover, so let's see how we do line crossover. So look at that, see the line, it's crossover because of those two dimensions have very limited space right here, from this edge to this edge, from this edge to this edge. I call this just edge. It's just a edge is where the two features meet, and then the feature change. So see, it goes up, and then the feature change going in, and then come back up. So from here to here is 1, and then from here to here is 0.688. But we can put this thing, you can take this out, you can put this in, however they will still be overlapped. So that's we call it a crossover, and you gotta try to avoid as much as you can. As much as you can in your drawing. You gotta do it only if you can't be able to avoid it. Because you can't break the line. It's better to use a continuous line like this. But of course, there are certain exceptions. At that time, you will have to do the crossover, but don't do it. Okay, it's not good. Because it's better that extension line don't cross over or under the dimension lines. Okay, so the very first one, don't cross over. Yeah, so don't draw your extension line crossing your dimension line. You want to avoid it at all costs. If you cannot avoid it, you can do it only if you cannot be able to avoid it. Second one, your inline, yeah, dimension. You can share arrowheads with contiguous dimensions when the situation is appropriate. Meaning, like, you can share the same arrowhead, yeah. If they're all like in the same alignment. Okay, so here 1.438 from here to here, and then from here to here 1.250 limited space, so we share the arrowhead. Your shorter dimensions, yeah, shorter dimensions, and you're gonna place it close to the outline of the part, yeah. So make sure you put the shorter dimension inside, yeah, that's what it's saying. So you have, in this example, so you look at this little 375, so 0.375, that's about like 10 millimeter away from that object, okay? And then you also have this little one, 0.2506 millimeter minimum spacing, yeah, from here to here. Shorter dimension put inside, a longer dimension put outside, and there should be that, yeah, minimum spacing in between them. Meaning you can put this thing way down and you can put that thing way up. It's got to be about 1.25 reasonable, yeah, spacing. The next one, so you don't have to give like all the dimension like this, yeah. If you put like the longer dimension, you put this, then we automatically can be able to calculate this part, yeah, by subtracting this, add it up, and then subtract it from here, so we get this. So avoid the complete, yeah, change of dimension, please. So this is just so clutter, and you have to like share the arrowhead forever, yeah. So it's when you have like too many dimension, edge to edge like that, you're gonna leave one out. Yeah, so that, but make sure you leave it, you know, in a sensible way, so that you can be able to subtract it. Extension line, yeah, should not cross other extension lines. See, this is, yeah, not very good. Of course, here in this example, you can avoid it, but make sure that you avoid at all costs. Yeah, just like here, extension and dimension crossover, extension and extension crossover. Try not to do it. Then also avoid the cross extension and object lines. So you have object line here and cross extension because of this little feature change right there. Yeah, make sure you avoid that. These are all the review from your MET 101, by the way. The next one is your angle. So angle, you can dimension. Make sure you use either coordinate location of the points or by locating the vertex of the angle. Yeah, calling out the angle by degree, either polar orientation or you can do like a vertex right here, 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 and then here is your angle. Yeah, you can pull this out like this and then give the angle right there, because this is like a greater angle, not just a smaller angle, and the whole thing is 180, so we can give this angle, yeah, because of this slope. You don't have to identify the slope by giving a larger angle. You can identify the same slope by using a smaller angle. Yeah, it's better. So make sure you practice that. Repeated features, yeah, we're gonna put like 4 times or 2, yes. So let me fix this picture. It's not showing here a little bit better. Yeah, you can see this. So it's a 4 times, so it goes white on white, as you can see. So 4 times 2.0 and 8. So going from here all the way to here, from here to here, yeah, of this part, your repeated feature starts, yeah, 4 units away from this surface. So go all the way down, and we're gonna give 5 of them here, yeah, at 1 diameter, 1 unit. And tolerances go all the way to 1.005, yeah. Same thing here. So make sure repeated features, yeah, you can call it out in a note like this. So this we call it a note. And avoid multiple references to the same, yeah, identical or feature. So here you can just show once, yeah, 1 circle of all this, a 5 circle, and then just use this a time node, which is time little symbol right there, yeah, X. All right, the next one. So dimension should be placed in views where the geometry is best defined, where true characteristics, designs, and geometric shapes are displayed. So let's take a look at this. So the very first one, yeah, we put in leader dimension. You put in the same thing, go slow, yeah, each one of them, following all the rules that we need to follow. The next one, yeah, smaller inside, larger outside, don't cross, smaller inside, larger outside, try not to cross over extension to extension or extension to dimension lines, extension or dimension to the object line, yeah. Leave one out, okay, and don't do the complete chain of dimensions. Then we go here. For the neatness, again, you got to align, yeah? From each view, got to be totally aligned. So here is showing the view relationship right there, yeah? So this thing won't like pop out way over there. Some students still doing it. All right, this one I can see. Let's just give it a little bit of color right there, so we can see, yeah? Okay. Here, leader, this is your coordinate dimensioning, yeah? And we're not using dimension lines at all, we're just using kind of like a little, yeah, node, which is your leader lines. All right, the next one. And when you study, again, don't go into details, okay? Just read and try to spot the most important point like this. So right now, dimensions are red from the bottom, yeah? And from the right side of the drawing, and that's an instance of aligned dimensioning reference, yeah, earlier in your presentation that we already showed, yeah, how to dimension from center all the way to each edge, yeah. So going like, it's a little bit different method, but it's the same thing, yeah, going 0, 6.25, and then up, going 0, and then 0.7, 5, 0, and then keep going, okay. All right. The next one, see how beautiful, yeah, dimensioning is. Feature sites and your location. You're gonna establish that from your index point on the part index means, yeah? Here, right here, your X, Z here, Y right there. So these are your indexes. This is called a tabulated, yeah, dimensioning. Not so many people use it, but just for you to know, I'm not gonna ask you that much of stuff, yeah? If you know a concept, that's okay. Just stick to your regular dimensioning, please. All right, next one. So here is your table, yeah? These are your tabulated dimensioning for feature, size, and location. So here you have your sizes, and here is your dimension right there, yeah, perfectly showing you smaller in, larger out, yes, totally aligned from two different views right there. Smaller in, larger out. Your XYZ axis right there, your front and your right view, okay, and here 1, 2, 3, 4 holes right there, yeah, and then another little 2, yeah, circles right there. So altogether 1, 2, 3, 4, 6 circles right in there, and diameter, yes, and then the center, yeah, how much far away from these axes are written there for you, okay. All right, these are pretty easy to read. Another part, this is section, yeah, it's a cut part. We do the same thing, follow our dimensioning rules, yeah, smaller in, larger out, yeah. No space, so we're gonna use a dimension out and value out, dealing with the cylinder, so don't forget your diameters. The same thing, yeah, and we call that staggering, yeah, this one, yeah, that's showing you a different placement of dimensioning, yeah. So we call this staggering. A little bit different from this perfect, yeah. Look at that. Because they can overlap to each other, so I'm trying to make it look like this, okay. So it's called the staggering in dimension value. We try to solve it this way, so you don't have to read, yeah. It doesn't look cluttered. Okay, here whenever it's practical to do so, what you have to do is your external diameters are dimension rectangular, or longitudinal views. So go up here 2, and then this 3. Okay, they're staggered, so therefore use a staggered dimensioning by making sure that the values are not overlapped to each other. Alright, and here that's your through, circle 0.25 diameter. So cylinders and holes, your slotted holes, and then your cutouts, they're irregular shapes, so you are going to dimension, in views like this with through, meaning through mean going through like this from little circle, medium, and the giant circle, they're through. See, like through right there, so you know that they're through to each other. Okay. All right, this one. So slots. How to dimension the slot? We're gonna do it this way. We can do 3 different ways. The very first one. So overall dimensions. With your general, radius right there, because slots, so we have 2 arcs, so we use a radius and 2 times. See, 1 here, 2 here, so we can only label it 1 time. The second one is going to be like this. Okay, slot width, and then distance, the width, and then the distance between the centers. So a little bit different from the very first one. That's just overall, and this one, this, and here the second one. So let's take a look at, see how different. Now you can see, so that's 2 times with this arc. Your width is on this side, yes, and then from here to here, instead of showing from the top of this slot to the end of the slot, we're giving in between. It's a little bit different. So that's slot width and distance between the centers. So that's your center of the first arc, center of the second, identical arc, and we're taking that distance. So a little bit different for slot dimensioning. Let's see the next one. Alright, the next one is slot width by length. Yes, so here you have your width and then your length, and of course you still have your arc right there. But in order to save the space and the clutterness, we'll take it out and put it together. So here is your width and then by length. So you have your width is 0.5, the length is 1. Pretty easy. Okay. So here you have the solid parts, fully rounded. This is your slot, and these fully rounded ends, we're going to dimension it first, given the overall, right? The first type is overall length and the width dimension, and then specific radius. Here is a part partially rounded. See, it's not fully rounded like this. This is perfect. Second one is partially rounded, and we're gonna dimension like this. So center points for radii are identified like that, and 2, 1, 2, 0.50 radius, and then the width, and then the length. Overall method. Alright, this one is a rounded corner. See, we have 1, 2, 3, 4 rounded corners, and we're gonna dimension like this. So parts with rounded corners are dimensioned to the edges of the part, here, here. And the radii, which is this one, are tangent to the surface. So your radii is your tangent, to the surface. So center for these types of radii, and they're neither located nor shown on the drawing. So you can't really see it here. So anyway, so overall, we're gonna label the diameter here, because it's a big circle, and then your arc, your radii, for your little 4 arc right here at the corner. These are called arcs, and then your width and length. So if you give like that, it's okay for all your rounded corners. Alright, next one. When you have your radius is dimensioned, where it's not shown in true size and shape. So here we use a through. Yeah. Of course, you don't have to remember all of these rules. You will get a sheet. Okay, you always have to go by. Do you remember this little pocket book that I told you to buy? And that is your cheat sheet. Okay. So you, if you stay in this line, keep that book because you have to go back and look at it. Yes, everything that we are studying, every chapter is right in that little pocket book. Okay, so make sure you keep it. So here, yeah, I'm gonna write that. So if you don't remember something, hey, I don't know how to dimension, then go back to the pocketbook and take a look at it. It's like your dictionary, okay? And no need to remember everything by heart. So you don't have your true size and shape will do that. You don't understand, well, I don't understand what I'm going to do right now. Don't worry about it, okay? You will get it a little by little. Meaning like, look at this. This isn't a true size and shape, right? This is. So therefore, when you have this, you got to write it through so that you understand that's not the true size, okay? Something else is a true size. That's what it said.